Hey everybody, it's Tony from Adafruit. And oh, I forgot to turn the lights on, so let's do that first. That might be a smart thing to do when streaming. So anyways, this is part 2 of the SQLite sensor storage series. And so in the first part, we looked at some basic usage of the SQLite database. Real simple, nice, easy to use database system, but very powerful, very capable. And we kind of saw how you can manually create tables and add data to it, and really just try to drive home kind of the comparison with a spreadsheet. You know, when you're thinking of sensor readings as just kind of time series data, so you have different columns of data, like a sensor value and maybe a time that it was taken, you might think of that as like putting it into a spreadsheet and having different rows for each of those readings. So we saw how to do just that using a SQL database, the structured query language. And so kind of saw, okay, here's how you write a SQL query, just the basics. You know, we didn't get into really advanced SQL stuff. And so that's where I wanted to start with in this second video, is look at another way that we could create what we created in part 1, but using something called an ORM, an Object Relational Mapper, which is basically just some code that abstracts away a lot of the SQL database logic for you. So it can actually write SQL queries for you automatically. It can create tables for you so that you don't have to deal with the SQL stuff in your code. And that's not to say that SQL is something you don't need to learn and that you can use ORMs exclusively. It's, you know, there's always limitations to things. And so that's why when you're dealing with databases, you know, just don't exclusively go down one path. I think you really should learn both. Like, you need to know some of the basics of the database at a low level and, you know, using SQL, and then also, you know, learn ORMs. And I'll kind of try to show why this ORM is useful, like why you might want to use it, because it does simplify your code a lot. It gets rid of a lot of boilerplate code and makes things a little bit simpler. But again, it's not just a, you know, complete replacement. You don't forget all the SQL knowledge. It's still really useful to go look at that stuff. So in this video then, I'm just going to rebuild what we built in part 1, where I just have a couple of these DHT temperature and humidity sensors connected to a Raspberry Pi, and then we'll have a database that defines each of the sensors, and then also we'll store all of the sensor readings so that the code that I write will basically read from the database, okay, which sensors do I need to use? And then every 2 seconds take a new sensor reading and save it to the database. And so that's where we'll go. And then I'm starting to think about you know, future parts of this series. So someone had mentioned comments, you know, can we look at maybe adding like a web interface, like a Flask application that reads from the database? And I think that's totally where I want to go. Maybe in the next video is, okay, you know, now we've got data in the database. What can we do with that? Can we like chart it? Maybe go back to like our Pi Internet of Things series and see how we charted data in real time, you know, using WebSockets. And a database is a perfect backend for getting that type of data, you know, and looking at it and putting it onto a web page for this. So that's maybe what I'm thinking about, where we're going to go with it. But let's just kind of dive in and get started with this series first, or this video. So we'll switch to the main view here. Let's jump here, and we'll go here. And before I get started, I just want to mention, so I didn't do a Monday stream this week because I was actually out in Portland, Oregon at PyCon, the Python Programming Convention. A really cool convention, the first PyCon I've ever been to. I've heard really good things about this convention, and from what I saw, it was awesome. If you ever have a chance to go to PyCon and you're interested in Python programming, definitely check it out and try to go. It ran really smoothly, like all the talks were on time, and there were hundreds of talks. It was over the course of like 3 days or so, and then even more days of like sprints and open spaces, like people were hacking on, but they might still be hacking. I think it goes until today, but I couldn't stick around for that stuff. Really cool though, met a lot of neat people. I wanted to call out one cool thing, one presentation, and I hope to do a blog post maybe next week to summarize some of the cool talks that I saw. I just wanted to call out this talk, and luckily all the talks are on YouTube now, so I think if you go to the PyCon 2016 YouTube channel, which I'll put a link in the description below when this is on YouTube, so you can go check these out. But this is a really good talk by Dwight Hubbard called Keeping Cool Using a Raspberry Pi to Create a Network Temperature Sensor. And this is really good. It's not super advanced. I think it was the perfect level of detail for the PyCon audience, because you got to remember, like, not everyone in the Python community is into hardware or really knows much about it. You know, that was the cool thing of going to PyCon is that you saw a broader spectrum of people. So lots of people doing like data analysis and stuff like that are interested in hardware, but maybe don't know where to get started. So this talk was a little more beginner oriented, but I thought it was really cool because he took a really good slow progression to kind of, you know, talk a little bit about Raspberry Pi, talk about connecting things to the Pi, the GPIO. So he was using the DS18B or so, I can't remember the exact number, but the one-wire temperature sensor was what he was using in his hardware, if I remember correctly, and just kind of introducing that, showing how to connect it. So really good kind of beginner level talk, I think, of, you know, if you're interested in using Python and stuff like that, and shows just how simple it can be for that. So wanted to call it out, really cool talk, you know, because I think it's actually harder to do a beginner focused talk when you're more of an experienced person, because you just want to dive into all the specifics and you want to gloss over things that you think are easy, like connecting something to the headers on the Raspberry Pi. Are a little more challenging for a beginner, like someone who doesn't know about it. So to take that kind of high level stuff and make it a beginner friendly thing, I think is pretty cool to see. So that was pretty neat. And then hopefully later this week, I'll do a blog post on other stuff I saw at PyCon. So, okay, let's jump in and see. So like I mentioned, an ORM, an object relational mapper, is what I want to use in this part of the video. And so the ORM I'm going to use is this thing called Pewee ORM. And there are a lot of different ORMs, like every big language has different ones. I know like in the Java world especially is really where ORM kind of usage took off, like maybe, gosh, 10 years ago or so, more than 10 years ago probably. I remember when I was in college, it was when we were starting to see a lot of emphasis on, okay, abstracting away the database like this. Pewee is really nice. There are other SQL or other ORMs for Python. SQL Alchemy is one that you'll hear a lot. Very powerful. It has, I've used it just a little bit, but it's, I mean, it powers a lot of big Python applications. It has lots of levels of abstraction, like there's a low-level SQL access layer in it, and then there's a higher-level object relational mapper layer, and everywhere in between there. But I looked at Pewee ORM, and I really like it because it's very simple, and you'll see, like, we just define a few classes, you define your data model, and then use a few simple functions to just create and query data from your database, and it does all the rest for you. There's not a lot of boilerplate setup, so really nice, really easy to use for this. And so that's what I wanted to use to get started for this. And so I'll put a link in the description below. This is the documentation page. You know, it's good to just check this out. They've got a quick start, and from what I've seen, the documentation for this project is really nice, so it's definitely worth checking out. And the quick start is pretty complete. It just dives right in and shows you, you know, here's what you can do to get started with this. So let's just kind of dive in. In the upper right here, I have the same hardware as I had in part 1. So I have 2 of the DHT temperature sensors, humidity sensors connected right here. And it's running the latest version of Raspbian. And then right here, I'm SSH'd into it, so I'm connected to the Pi. And we'll just kind of get started here. So I'm going to go outside of this directory. By the way, I put all the code on GitHub for these projects. I'll put a link in the description below when this is on YouTube, so you can see that. And let's just make a new directory. We'll say this is part 2, and we'll go into here, and we'll get started with some of this code. Now, to install Pewee ORM, it's really easy. You can just use the pip tool to install it. Remember, I'm using Python 3 for this, so you want to use the pip3 command. And you want to run it as root, although at PyCon, I saw some really good videos, or some good presentations that talked about how doing sudo pip install is probably, you know, one of the worst things you can do. A lot of complicated reasons why, mostly for like when you're in a production environment and you've got like servers that you need to have in some known state. So it's, in a lot of cases, people create what's called a virtual environment. I don't do that in a lot of my videos here, mostly for simplicity, but maybe a future live stream I should look at, you know, using a virtual environment, why it's interesting, what it does under the covers and things like that. So, you know, I'm sure the experienced PyCon or Python people are probably freaking out at this point. But all right, so sudo pip3 install Pewee. So super easy to do. And I already have it installed, so it just tells me that it doesn't need to do anything. But after you do that, it's installed and it's ready to go. And the quick start here kind of talks about it too. And they kind of show, okay, so to start with an ORM, instead of creating your tables and your database with SQL code like we did in part 1, you describe your database and your tables in Python code. And so that's like this example here. And the way the Pewee ORM works is you create instances of this model class. And this model, it's a class inside of the PWORM, so you inherit from it, and then you specify, okay, these are all the fields in this object, this thing that's going to live in my database. And so these are actually just class instances of certain types that PWORM defines. So it has like a character field, date field, Boolean field. You know, these map directly to different column types in SQL. So, you know, when you create a table, you define the columns inside of there. You have to specify each of the types. And if you remember in part 1 of this video, actually we'll jump back to the part 1 code. If I look at this guy right here, you know, remember we had to execute these create table commands and say, okay, I need my sensors table has a name column of type text and a type column of type text and a pin column of type integer. So with the PWORM, you do that same definition, but you don't do it as SQL code. You do it as Python code here. And then that way the PWORM can know, okay, there is a person object, and I need to create a table to store instances of this person object, for example, in here. And this person object has a name and a birthday and an isRelative field. So I need to make sure that I create all those columns. And this can get really advanced. Like you can do all kinds of attributes on these different columns. You know, you can like define this is a primary key, these are foreign key relationships. We're not going to get into those, but it has all those capabilities built in. And then you do this weird little meta thing here, which is just a little quirk to say, okay, I have an instance of a database, and this model class talks to that database. So it's some of the very few bits of boilerplate code that you see in using the PWORM. Okay, so you might be wondering, like, why go through this trouble? Well, the cool thing is, once you tell PWORM about your person object, it knows everything it needs to talk to that thing in the database. And just with the single function call, you'll see it can actually create the table to store this object automatically. And with a single function call, it can generate all the SQL queries to go grab instances of this object. And you can do pretty much everything that a SQL query can do. Like you can say, I want to filter by some specific column value, or I want to sort them in a certain way. You know, you can get really advanced with it. And so the nice thing is you're not embedding all that SQL query code into your Python code where it gets really confusing and it's kind of hard to follow. And you're doing all this string processing in a lot of cases. You know, the PWORM is smart enough to generate that code for you and talk to the database. So it kind of abstracts the database away from you, you know, at a lower level, which in some cases is good because you can actually change the database you're talking to. Like PWORM, it supports SQLite, but you can just point it at a different database instance here. You know, instead of creating a SQLite database, it supports like MySQL and PostgreSQL and all kinds of other databases. So that's really powerful in that, like, maybe you do some basic code and you're testing it just using SQLite on your machine, and then you want to go more advanced and have some crazy, you know, web service layer, and you want to use like a proper database engine like MySQL or PostgreSQL. It's pretty easy to do that. You just swap out and say, okay, I'm using a different database instance, and then PWORM can know how to generate, you know, maybe there's specific things for that database engine that it needs to know. It'll do all that for you. You don't have to worry about it. You don't have to go in and change your code and start writing different SQL queries, although in most cases the SQL queries hopefully are going to be the same across your database engines. So that's the power of it. And I think you'll see in this example that the code is greatly simplified when we use an ORM because, you know, if you remember from our part 1 code, you basically see in here, like, let's see, where was some of the SQL queries that I did? Like, you know, right here, I'm doing execute select name type pin from sensors. Like, okay, what does this line mean when I'm just looking at this? Like, I'm executing a SQL query, but it's not obvious that this is actually reading all of the sensors from the database. So you'll see with PWORM, it's a little more obvious, it's a little easier because you're going to use these model instances rather than just directly running SQL queries. And the cool thing too, I should also say, is that PWORM, it has an execute function. So if you want to get in and just query the database, you know, maybe you run into some limitation, the power is there. It doesn't really try to hide it from you. It just tries to build on top of the database and make it a little bit easier for you for this. So, okay, let's see. Let's just close out some stuff here. I already wrote a lot of this code to start with, so we'll kind of start fresh. And let's see, I have connected to, oh, let's see, I need to connect to my Pi again. So let's open up the Raspberry Pi, and let's go to the iMac and the Raspberry Pi, and the part 2 folder is what I want to open up here. So hopefully, there we go, that opens. So let's make a new file. And let's call, we're going to start with, I'm going to make a model.py file. So I'm actually going to break this up into two different files. I'm going to have a model file and my dhtread.py file, which is my main loop that reads the sensors. And the reason I'm doing that is because I want to abstract it away so that my main code, my dhtread.py, can use all the classes inside of this model file. I don't necessarily have to define those classes inside of my dhtread.py. And that's useful because I might want to write some code later that uses this same data model, that talks to the same database, interacts with the same sensors, looks at the same sensor readings, but I don't want to necessarily have to like pull in that dhtread.py file. So I think it'll be a little more obvious once we get to the implementation, and I'll kind of explain why it's useful to break things down like this. But it's generally an abstraction that you see a lot in database kind of driven applications. You have usually what's called like a model layer, which wraps all of your database access. And then that layer exposes just high-level functions, things like adding a sensor or getting a sensor. And then internally, that model class can go in and it could do raw SQL, or it's probably going to use an ORM or some layer like that to make it a little bit easier for it. And the cool thing is then your dhtread, your main code that uses the model, doesn't have to know or care how that model is implemented. So, that model might be talking to a SQLite database, it might be talking to MySQL, it might go talk to like an Amazon Web Service database, maybe just a little in-memory testing database, something like that. That gives you a lot of flexibility in that your code is written to use this model, and then you can just plug in different model instances later if you want to change how your code works without having to rewrite it here. So, okay, cool. So in the model then, I'm just going to kind of get started with the quick start here from the Pewee ORM. So let's just copy this out, and we'll use this as a base to get started with. So the first thing is that you import the Pewee module here, and then you have to create an instance of your database. I'm just going to add a little more spacing here. And in this case, let's call it dht.db, just to match what we did in the previous one. And then you need to create an instance of a class you inherit from this model class that the Pewee ORM provides. And like I said, you have to fill in all of the fields that define each of your model instances here. So let's just start with our DHT sensor, and this will inherit from model. And then if we go back to our part 1 code here, let's see, let's look at our DHT read. So our sensors had a name, a type, and a pin associated with it. So let's add that to our class here. Oops, let me find the right window there. Let's move that out of the way. So, okay, so name, we've already got that. We'll keep character field. And you might wonder, like, what are the possible types of fields that I can have here? And so there's a great little page in the Pewee ORM documentation, this model and fields page. I'll put a link below to this. And if you scroll down, they've got a great little table here. Super handy because this kind of shows, okay, the car field or character field in SQLite just turns into a varchar, which is a little database specific. This basically means a variable length string. And in SQLite, there's almost no limit to the size of these strings. Other database engines sometimes impose a size limit on these. In SQLite, I was reading, it has like a 1 billion character limit for these, so we don't have to worry about the size. But it is something to think about. If you're using other databases, you might have some limits there. There's also a text field, and usually in a database, a text field is a very large text block. Like it could have lots and lots of characters of data, like kilobytes of text sometimes. And so that's usually a distinction there. Well, let's just stick with car field though. I think this is fine for our needs here. So let's use that. And then I had a type. I'm going to say DHT type as the name of my field. And for this one, I'm actually going to use an integer field for this. And if you remember in the first one, I had a type column of type text, and I would store a value like DHT11 or DHT22 because I need to know the type of my DHT sensor. I happen to have DHT22 compatible sensors here, but there is a DHT11 and an AM2302, and they're slightly different. The code has to know which type of sensor we had here. So in the first part, I just put a text field in and just wrote DHT11, and then you saw I had to do this conversion to say, okay, if I get DHT22 back as a string from that field, actually use this Adafruit.dht22 value, almost like an enumeration value. This is literally just a variable. But I'm going to simplify it because this Adafruit.dht22 is actually an integer. It's not something that's easy to tell. You have to look at the code for this, unfortunately. So I maybe want to think if there's an easier way to do this. But this will make it simpler in that I can just store directly in the database this integer value, and then that way I don't have to do this little conversion when I get my data back, to convert from string to integer. I'll just save that integer value directly and then use that in my code later. So that's why I'm going to change this to an integer field here. And then the last thing was, what was the last thing here? It was, the pin number that it's connected to. So let's just say pin, and again, this is an integer field for this. So we'll save that. Now this meta thing, again, this is kind of the boilerplate that you need to do. You have to tell kind of the Pee-wee ORM, okay, this is the database instance that this model instance is going to talk to. So this is one way to do it. There are other ways, I think, to do this. Look into the Pee-wee documentation, but this works. It's not too bad a boilerplate. Okay, and then the other instance I want to create is my sensor reading. And so again, this inherits from model. Now I need to define all of my fields for this. So if I remember correctly, let's see, I had a time, a name, and a value for each of these. So let's just put that down. So we'll say time, name, value. Now the time field, this is actually kind of nice. There is a type inside of Pee-wee ORM, this date time field. And the cool thing, this is where using an ORM is very useful. It knows how to map from the Python datetime type to whatever native datetime type your database uses. Like in SQLite, there's a datetime field. In PostgreSQL, there's a timestamp field. It'll do that automatically. I don't need to worry about that, how to define that. And so the cool thing is I can just throw a Python datetime at this and it will do the right thing and convert it into whatever format the database needs. And likewise, when I read back an instance of a sensor reading, it's going to know, okay, this is a datetime field. I need to convert this into a Python datetime object, so I don't need to do any of that conversion myself. I can instantly just start getting like the hours, minutes, seconds off of that field. So super handy, and that's really a big reason to use an ORM, that it does all that boilerplate code for you. Because you can imagine, if you have a really complex data model, like hundreds of different classes with lots of relationships and different types inside of there, your code can get really complex, because as soon as you read something from the database, you've got to do that conversion from your database type to a Python type. And that gets really tedious. It's very easy to mess something up accidentally. And if you don't have good tests, you're not going to realize it. And then you're getting bad data back, and everything goes badly. Whereas the ORM, it's built to be generic, and it knows how to do this stuff automatically. So, you let it take care of that kind of drudge work or boring stuff for this. So, okay, cool. So I've got so my time type, I'm going to say, is a date time field. The name, we'll just do a car field again for this. And then the value, this is a float field, if I remember correctly, is how they define it in the fields here. So yeah, there's a float field. You could use double field also if you wanted, but I think this sensor only gives you at best like 2 or 3 decimal points of precision. And then yeah, datetime field is the name that I got right. I just want to double check. And then there was one other field name that I had in here. Let's just see what I had. Oh yeah, integer field. Let's just make sure that I got this right. Yeah, integer field, that's the name. Okay, cool. So those are the fields. And then again, I need to do that boilerplate. So I'm just going to copy this out to make sure that our class instance gets this. So, okay, cool. So that's all that I need to define this data model. Now I'm going to do a little bit extra stuff here. So I'm going to make a kind of a data access layer is how you might hear it referred, or basically a class that takes care of connecting to the database and really exposes all of the functions that my main code will use. That way this class can have all of the logic that uses the Pee-wee ORM or whatever it needs to talk to the database. So it's all in one spot, it's all in one class, and it's a little bit easier to deal with it that way. So I'm going to create that. I'm just going to call it the DHT data. It's always really hard to think of a name for this type of a class, because there's one thing I remember reading, you might be tempted to say like, oh, I'm going to call this the DHT data provider class or something like that. And if you're coming from a Java background, this probably feels like, yeah, that's actually not descriptive enough. We need more description in here. But I don't like naming things like provider or, layer, some intangible thing. I like to name a class as something that you can, kind of think about and reason about. Provider is a very abstract thing. Like, what does it provide? So it's just a weird little style note. Now, I don't really think DHT data is necessarily any better. That's still a weird kind of name. But that's, these type of classes, I never really think of a good way to name them. So there's some kind of joke. It's like, what are the 3 hardest things in programming? Naming things, off by 1 errors, and something else. And naming things can be pretty challenging sometimes. So at some point you just got to say, okay, I'm just going to name it like that and live with it. And there are lots of good tools to refactor things today, so that if you want to change your name later, you can. You're not stuck to it. So okay, what does this thing need to do? Well, it needs an initializer, so we'll do that. And basically there is a little bit of boilerplate setup. If we go back to the quick start, so they talk about, here's the model definition, and then you actually have to call this db.connect function. You don't have to, it says, but it looks like it's best practice. So basically this will tell PWORM to go talk to the database. So I'm going to do that in the initializer here, and I'm just going to say db.connect. Now it might be a little bit weird here in that I've got this global variable db up here, and it's kind of ugly to have global stuff. Luckily in Python, it's something where you can have global variables and they just live in that module, and it's not as dangerous. Like, people aren't going to automatically get this thing. So it's not too bad to have that. But it has to be global because like these classes have to plug into it. And I haven't looked super deeply into PWORM. Like, maybe it has a way to dynamically add these, but it's not the end of the world to have a global like this. Okay, so I'm going to connect, and then I'm also going to add a close function. And this is just good best practice. So the DB class also has a close function. It's smart. In my main code, I can make sure that I always close my connection to the database, so that if there's anything like a pending transaction or whatever, it makes sure to clear all that out, rather than just abruptly stopping, which sometimes might be bad in that case. So okay, so I connect to the database. Now here is where it gets really cool. So this create tables function, you give it instances of the model that you created. So like, this model class we defined above, and it will go and create those tables in your database. It will generate the SQL commands. It will run them. It will make sure they worked. It knows how to convert all of the Python types into SQL types and all that. And that's the really powerful thing I think about an ORM, is that you can use a command like this. It can know how to generate this database. Because if you remember in our previous video, we had to use the SQLite console and then manually run those create commands. So this is cool. This is going to do it automatically for us. So let's add a call to that in our initializer. So we'll say db.createTables. Now you pass it a list of your model instances, or model names, class names rather here. So your DHT sensor, and then your sensor reading type. Now there is a parameter here. They don't show in the quick start, but I'm going to add it. It's called safe, and it's a Boolean. If you set it to true, what it does is it looks to see if these tables already exist. And if they do, it won't do anything. If they don't exist, it'll create them. If you don't have safe equals true, by default it's false, and I believe it will actually drop the old tables and then recreate them. And so you could, in your initializer, like look and see, okay, do I already have these tables? And if not, then call create tables. But I'm just going to do this safe equals true and let PWORM do it itself. And so again, this is really nice. They really made it simple and easy to use for this. So, okay, let's save this, and then let's make a new file. Let's make a dhtread.py that lives next to this. And this file, I'm going to actually import my model. So, remember in Python, if you have different files in the same directory, you can import one of those files directly and then call the functions and use all the things and use the classes inside of there. Now let's create a instance of my DHT data class here, and so we'll do that. And then let's just call data.close. So I don't have a lot of other functions implemented yet for this. Let's see what happens though. So remember in my model, I'm just basically going to create the tables and then close the connections. So if we go to our py right here, you can see here the 2 different Python files. Notice there's no database file here yet. There's no dht.db. But let's run python3 dhtread.py, and let's see what happens. Oh, it fails. DHT data is not. Oh, so yeah, this is a kind of common thing for beginners sometimes. So I imported model, but that just means that model is in the global namespace. And if I want to use this DHT data class, I actually have to prefix it with model.dht data. I could say from model import DHT data, and that's probably the better way to do this. So let's do that. That's maybe the more Pythonic way to do it. So we'll do that. And then we see, okay, nothing happened, but let's look at the directory here and notice we have a dht.db file. Okay, cool, something created the database. Now let's look at, I'm going to use that little tool that I like, SQLite Studio. So this is a nice little graphical tool I showed off in the first video on, it can connect to a database and then show you, here are the tables and things. So let's connect to our database here, and I need to jump up a directory. So yeah, I want the DHT-DB file there, and don't make it permanent. Say, okay, so there's that. Okay, cool, so notice this. It created, oh wait, this is a little weird. That's not the right database. Let's see, wait, let's disconnect. Let's remove this. Make sure, I think I might have picked the wrong database. Yes, I'm gonna remove that. So, okay, let's go back. Let's make sure that I'm getting the right database here. Let's go to that, okay. And I'm in the part 2 directory, duh. So that's the database. I picked the wrong database file. All right, there we go. So there's that. Okay, here we go. So notice there are 2 tables in here. I never executed a create table statement in my code or elsewhere. It was all from PWORM. So it created a table called DHT sensor. And if you notice, that kind of matches the name of our class here, DHT sensor. And it populated it with fields. So it added a name. It looks like it actually created as a varchar 255. That means this can only be up to 255 characters long. So I guess good to know. The default for this is 255, which is more than enough for our needs here. But it added, so let's look just directly. Like here's the name field that it created. Here's the type, DHT type, exactly the same name there. It's an integer field. Pin, that's an integer field also. You might notice too, though, it created something else. It added this ID field. And this is a pretty common practice in databases because I didn't really define any of these as a primary key, which just means that a primary key is a column that has unique values. Like only one row can have that a specific value. So if I had if I made pin the primary key, and I had 2 sensors with a pin value 25, the database would not let you create one of those rows. It would fail because it has to ensure that only one row has a specific value of that primary key. And it's useful, like the database can be smart, it can optimize things. Like if it knows that all of the values in a column are unique, it can build an index so that it's really fast to look values up automatically. Now the cool thing is PWORM kind of realized that I don't have a primary key, and so it created one. It made this ID field. And I don't actually have to know or care about that in my code. This is all like purely something that PWORM will do internally. And it's just kind of a smart thing. Usually you want some kind of an ID with a primary key so that you can go in and uniquely identify a row of data without having to go through like, okay, if every single column value equals something, then that's the row I'm looking for. You can just say, okay, for this sensor reading, here's its ID value, and if I ever want to go back and like delete it or update it, I can just use that ID to get to that sensor reading. So it's cool that PWORM does that automatically, like it knows how to do that, but it's even cooler that I don't have to know or care about that in my code. It's just, if PWORM needs an ID field, it's going to go and create it, but I don't need to worry about that. And the same exact thing happened with our sensor reading field here. So you can see, it saw the sensor reading class that I created a column for each of those different types, and set them as the values that I specified here as the different types here. So that's pretty cool. Just a couple lines of code here, and we've got a database created, and we're ready to go with that. Now there's no data in these fields yet, so that's kind of the next thing that we'll get to for this. So okay, cool. So we've got our model, we've got our database that we can access. So the next thing I was thinking, let's add a function in here to define each of our sensors. So this will populate the DHT sensor tables to say, okay, for each of the sensors I have connected to my Raspberry Pi, I need to add a new row here. And so let's make a define sensor function. And this should take in the name, like basically every field for my DHT sensor class up here, because I'm going to create an instance of this thing. So I need to take in the name, the DHT type, and then the pin that this is connected to. And then what I was thinking for this, so in my main code, I'd like to just be able to call data.define sensor, and say, okay, here's my DHT1 sensor, and it's a type of, and let me import, I need to import the Adafruit DHT library. So this one is a type of Adafruit DHT.DHT22, and then it's connected to pin 18. And then I also want to be able to say, since I have two sensors connected to this, you know, let's define my second sensor, and this one is connected to pin 25. I'd like my main code to be like this, and for it to be smart enough so that if those sensors aren't defined, it will go and actually add them to the database. And if they already are defined, then don't do anything. You know, just use the existing rows in the database. So that's what I want to do in my define sensor function here. Now the cool thing is PWORM actually has a function to do this automatically for you. They don't show it in the quick start, unfortunately, but if you go into kind of the API reference, you can see that each of the model classes has a get or insert, I believe is the name. Let's just take a quick look at the API reference. So if I look at the model, and if I scroll down, it's got all kinds of functions in here, delete, raw. So they have a get or create. I think that's actually the one that I want to use. Yes, I believe so. So the confusing thing is they actually have a create or get, and they also have a get or create. And there's a very subtle difference between these. It basically says the create or get one, it doesn't, what did it say? They had a better part of the doc somewhere, but there was basically a difference where it won't enforce certain constraints on one of these. But what I ended up finding that I needed is this get or create function here for this. And so basically what it does, it will check to see if a field or if an instance of this model already exists. So if there's a row in the database that has exactly the same column values that I'm trying to create, and if it does, if that exists already, it won't do anything. I think it'll actually just return that back to you. But if it doesn't exist, it'll actually it'll add that new row. And so that's what I want to do here in my code. So if I go back to our code here, and then the way you kind of operate with PWORM, when I want to deal with my DHT sensor table or the objects inside of it, I use the class. And so PWORM actually adds all these functions to the class. So I can say get or create, and then I can just pass in. So this takes in as keyword arguments all of these fields rather that are defined. And so I just need to map from the parameters that are passed in to the fields right here. And so luckily, you know, I named them all the same. So it's just a direct mapping, DHT type to DHT type, and then pin equals pin. That's all that I need to do. And then the cool thing is, you know, PWORM, it'll query the database to see if this row exists. If it doesn't exist, it'll actually do an insert into the database. It's smart enough to know how to escape the SQL parameters and all that. You know, you don't have to worry about all that code, because if you remember back in the first video, you know, I had to manually run these insert commands and stuff like that. So none of that has to happen here. This is cool. This is pretty simple. So okay, I think this is enough to define our sensor. Let's save this and let's run our code again and let's see what happens. So okay, nothing happened there, but let's go back and let's read our DHT sensor table here. So if I go back here, check this out. So now I have two rows inside of here. I have a row with DHT1, it's a type 22 and pin 18, and then DHT2 on pin 25. And if I go back to my main code, hey, look at that. It's exactly the code, or exactly what I defined here. Now let's see what happens. I'm going to run my code again, exact same code. So, you know, it called this define sensor function again. And let's see what happened at the database layer. You know, if something went wrong, I might see multiple rows, but I don't. So, you know, you can see I still see just these two rows. And that's the cool thing about that get or create function. You know, it went in and it actually saw that these rows already exist, and so it just didn't do anything. It turned it into a no-op effectively for this. So, okay, that's cool. You know, just a few lines of code. I've added my sensors here. So now let's look more at the main loop that I want to do. So, you know, once I add my sensors, then I'm just going to loop forever, and every 2 seconds I'll go through each of the sensors, grab their reading, print it out, and then save that reading to the database. But first, maybe let's just get down to printing them out. So I'm going to need a main loop. So we'll say while true. And I also need to import time because I need to, use the sleep function in here, because I want to delay for 2 seconds. And I'm also going to wrap this all inside of a try finally block. And that's so that I can make sure I call this data.close at the end of my script, so that I jump into my main loop. If something goes wrong, or if I press Control-C to exit, it's going to throw an exception, and then no matter what, it's going to make sure that it calls data.close so that it closes my database connection from my data access layer here. So just smart to do this. There are other ways to do this. You could use a context manager class, but I'm going to keep it simple with a try finally here. So okay, this is cool. Now, basically, I just want to loop through each of my sensors. So I need some way to get all of my sensors. So let's go back to my model class here. And also, just as an aside, you might kind of notice, like, this is pretty cool in that, my main code here doesn't even import PWE ORM. Like, it has no idea that I'm using an ORM. It has no idea I'm using a database. I'm only talking to this DHT data class that I'm defining in my model. So that's kind of cool. Like, my main code isn't really, you might hear it referenced as coupling, where, two pieces of code are tightly coupled if, if one references like the structure or the internals of another piece of code. And generally, you want to reduce coupling in a lot of cases. Like, you don't want to have two pieces of code that rely on each other, because you're going to forget about that relationship. You're going to go change one piece of code and then not remember that another piece, another file depended on some structure in that code. And then suddenly you forget about that, and then you've got all kinds of bugs or things stop working. So, the less tightly you can couple things together, the better. But there are cases where, like, you have to, like my data access layer here, it has to know how to talk to the PWE ORM because it's got to save that data. So, it's not like a religious thing of like, you can't have any coupling, but it's be smart about where you put it, basically. So, okay. Now basically I need to, I wanted to add a function to get all of my sensors. So let's just add a get sensors function to my model class here. And this one I can actually go back to the quick start and see what they were showing here. So they talk about how to store data, and we'll come back to this. So retrieving data, they show you can use this kind of syntax where they have a select function, which is very similar to, as if you saw in the first video, the select statement in SQL. And you can add on, like they kind of use a convention here of chaining different function calls. So you call the select function, and then if you want to filter it, you call the where function on the output of that select. And then you can get like the first instance and stuff like that from it. Now, luckily, our needs are pretty simple. I just want to get every sensor. I don't need to do any filtering or anything like that. So they kind of show right here, just call select and then iterate through all the things you get, and you'll get all your instances, or all the rows of that table there. So that's really all I need to do, is just return DHT sensor.select. And then as long as I loop through whatever I get back from get sensors, that will let me see all the sensors in my code. So let's do that. Let's go for sensor in data.getSensors. And maybe just to start with, let's just print out. We'll just say, name. We'll say type, and then pin. And let's just do format. And this is the nice thing too, in that this sensor class is an instance of this DHT sensor object, and it has the name, DHT type, and pin fields on it directly. So if you remember from our earlier code, when I got stuff back from the database, it just came back as a raw row, and I had to do this conversion to say, okay, the tuple of all these row values actually mean these different variable values here. But this is cool. It's much cleaner when I'm using the ORM like this, because my sensor object actually has a name attribute on it, and it also has a DHT type attribute, and then the pin attribute on here. So it's doing all that work for me. I don't need to worry about that or care. So okay, so this is just every 2 seconds is going to print out the name, and that's fine. That's maybe not the most interesting thing. Get sensor. I think that's actually get sensors with an S. Just make sure I got that right. Yeah, get sensors. Okay, there we go. So now let's save that and let's run this. So okay, cool. So every 2 seconds, and we're seeing exactly the sensors I expected there. So that's working. That's not too crazy. Okay, let's go back, and now let's actually take a sensor reading, and maybe I won't print this out anymore for this. So okay, and actually for this, I'm just going to go back to our old code from part 1, and let's just grab, here's the line that reads and writes out the sensor prints out the sensor values. So we'll just grab that and use it because it's going to be the same here. So I've got humidity, temperature. I call my Adafruit DHT.read retry. Now I need to give it the type. So this is my sensor.dht type and the pin. So my sensor.pin. And then it's going to print out, well, it's going to return back the humidity and the temperature. And then it's going to print out, the name, the humidity, and the temperature value that it got. And so right here, I just need to make sure that I use the sensor.name. Humidity and temperature are okay because these are just local variables that were defined right here. So, okay, cool. Let's save that, and then maybe I'll just get rid of that white space that wasn't necessary. And now this time, because I'm using the DHT sensor functions, remember they have to run as root because they use direct access to the GPIO registers. So I'm going to run with sudo, and let's do my dhtread.py now. So let's see. Okay, this is cool. So we got our sensor readings here. This is pretty easy. And I'll blow on one of the sensors so that we can see the humidity go up on it. So if I blow on that one, we should see, I think that's DHT1. Yeah, so you can see DHT1 just jumped to 73%, and I kind of blew on the other sensor too, so maybe that was not the best. I'll see if I can move that guy away. But it looks like it's working. So we've got, our humidity values, our temperature values here. So, okay, cool. So we'll close that. So we're pretty close to having this thing all ready to go. And hey, we're only like 45 minutes in. So this is cool. It's a lot faster, you can see, than the first video where we had to write all these SQL statements and things like that ourselves. So, okay, so the last little thing I need to do then, after I print out these sensor readings, I need to save them back to my database. So if you remember, in the model here, so I have a sensor reading model, and that corresponds to this sensor reading class right here. And so this is actually pretty easy. So the way that you can create a new row in the database, if we scroll back up in the quick start, they kind of show you can create an instance of your model class. Like I could create an instance of the sensor reading class, and then you can just call this .save function, and that'll go and write that instance to the database. Or there's a little shortcut on the model class. They have this create function, which will just automatically go and create an instance given the values that you pass into it. And so I'm just going to use that here. That's really all that I need to use in my code. So let's go back to our model here. Now, again, I could put this code into my main loop, but I don't want to be tightly coupled to the PWRM. So I'm going to add a function to my model here, and let's just say add reading. And this needs to take in the name of the reading, and well, actually here, all the values right here. So the time, the name, and the value of my reading. So, okay. And then here I'm just going to call, now it's the sensor reading class that I'm using. So I'm going to use this, and we call the create function. And then again, I just have to tell it, here are all the attributes and how they map to the parameters of the function. So it's just one-to-one. It's pretty easy. Okay, so that's straightforward. And so I'll call create, and that's going to take care of like adding to that row to the database, making sure that it was added, that type of stuff. So real simple and easy to use that. So okay, so I save that, and now in my code, now I can just call data.addReading, and I need to pass in the time, the name, and the value. And so for the time, actually, I'm going to import the datetime class, because remember, I defined my model with a datetime field, and PWRM is smart enough to know if I have a datetime instance, it can convert it into whatever native type my database uses. So for this batch of sensor readings, because I want them all to have the same time associated with them, so I figured I'll just do it outside the loop here. But I'll say my reading time equals datetime.datetime.now. That's basically, the datetime module has a datetime class inside of it, and that has a now function you can call. I hate the syntax. I wish Python had a shorter way to get the current time as a datetime object. It's ugly. I mean, you could go up here and say from datetime import datetime, and then you only need to have one of these date times. But even that's ugly. It's like, come on, guys. There's got to be a simpler little one-liner for this, but it's not the end of the world. So, okay, so now I need to tell this thing, okay, the time, that's my reading time. And then if you remember from the first one, I'm not actually using the sensor name, because remember, each sensor has two different things it measures. It measures both the humidity and the temperature. And so I stored that as two different strings. Like basically for each sensor reading, I wrote two rows, one row with the humidity, one row with the temperature inside of it. And you can actually see that here, like, I did these two insert statements, and the name that I was inserting was the name of my sensor and then humidity inside of there. So let's just do that same convention in our code right here this time. So the name will say, we'll store humidity, and this should be my sensor.name now. And then the value is actually the humidity value that I read up above right here. And then the next thing I want to do is I just want to copy this and do the exact same thing for temperature. So same reading time, this time it's temperature, and then this time it's the temperature value that I want to store here. So that in theory is it. I mean, notice how much simpler this code is compared to the first iteration. This is from the first video where I've got like 2 different programming languages effectively. I've got SQL code embedded inside of Python, and I'm looping through rows, and it's not obvious what I'm doing in a lot of cases, versus this code where I've just got this DHT data instance, and I'm just saying, hey, define these 2 sensors, and then jump into my main loop, read the data from my sensors, add those readings to the database, and that's it. Just do that every 2 seconds. So let's see what happens. I'm going to run this and make sure everything's working. So looks like we saw a couple sensor readings here, so that's cool. Now let's go back to our SQL Explorer, and remember, this is connected to the exact same database. So let's look at our sensor reading table, and let's see, let's refresh this, and hey, check this out. So notice we've got some data in here now. So we can see there's the time, and this is cool in that it converted my Python datetime type into a native SQLite datetime type. So it's a little bit easier to operate on this. In the first video, I stored these as an integer with the seconds elapsed since the Unix epoch, which is always a pain in the butt to deal with. So this is cool. It's more of a native datetime type. Here's the name, humidity, and temperature, and then here's the values for these. And so if I refresh this, you can see it's adding more and more rows as we go. And I can go in and just start querying this data. So if I write a SQL query, let's just select maybe the top 10 rows from my sensor readings table. Select, top 10 star actually is what I want. So select all the columns, the top 10 rows basically from this, and then let's execute this. And oops, I got something wrong. That's weird. What is this complaining about? Well, here, let's just, instead of doing that, let's just do select, it's not sensor readings, it's sensor readings. So, okay, let's do that. Let's put the top 10 back. All right, now let's execute that. And, oh man, I got something else wrong. Jeez, this is not a good time to be writing live SQL. You can tell I'm a little rusty on my SQL here. So, but you can query this data. As you saw, the data is in the database here. So let's see, let's go back to the data here. And I can refresh this and see more. I'm going to get this thing to work. I don't know why it's not, why I'm not doing the query right. Let's do select star from sensor reading. Maybe I misspelled it. Let's try that and see. So, okay, there we go. Maybe SQLite doesn't top 10 star. Huh, okay, maybe SQLite. So my main experience with SQL was from MS SQL, Microsoft SQL database. So that's the big thing. Each database engine is a little bit different. Some of them have different functions they support. So it looks like SQLite doesn't have the top function, which is actually a really handy function. But maybe it's there. Maybe I'm just doing it wrong. So, but you can go back and we can filter these things, like like we saw before, where the name is like, which means, it's like a star search, like humidity. So this is going to say, okay, find all the rows that have something, this is like an asterisk, like when you're searching for anything, and then ends in humidity, like space humidity here. So if I hit this one, notice I'm only getting back the humidity sensor readings in this case. And I can get more advanced, like maybe where name like humidity and value greater than 60, something like that. So, or how about value greater than 61? So now I should see, less rows in here. And so yeah, notice I'm only getting the 63 values inside of here. So, real powerful, really cool. We showed this a little bit in the first video that, SQL is a great language. But I think that's it. I think I'm going to wrap it up for this video. So I really just wanted to show the power of using an ORM, the Object Relational Mapper. And, I think the best explanation of this is looking at just the code for this example that we just wrote, and even the model code, like this is not that complex. It's pretty easy to follow this. I create these classes that just define my tables effectively, and then I'm just using all these functions that PWORM defines. It'll go and create these tables automatically. Compare this to the previous code where I'm just writing raw SQL statements, and it's when you just glance at this code, it's not obvious that this block of code is reading all of the sensors. It's like I've got this execute and there's something going on in here, and then I'm like iterating through rows and I'm converting stuff, and it's like, then I've got these big if statements that are ugly and doing this conversion. It's like, what's going on here? Versus in this example in my DHT read, I'm basically just calling data.getSensors. Like this function call is exactly the same as this block of code inside of here. So, great simplification. But again, like I kind of said early on, ORMs are not like a magic wand that just instantly makes using databases easy and perfect and you can never screw up. It's a tool. It can help you, it can hurt you. And so that's why, like I said before, it's useful to know both. Like learn a little bit of SQL and then learn enough SQL to know why it's useful to use an ORM, to realize that like doing a lot of these queries and boilerplate stuff can be kind of error prone and annoying in that case. So yeah, that's the end of it. If people have questions, throw them in the chat, and I think I'll see if I can get through them here. Let's see, let me change back to the main view here. So yeah, there's the main view. Okay, let me scroll up here. I think there are a lot of questions and things going on. So okay, question, what's the maximum transaction rate of SQLite versus other databases like MySQL? Good question. So I don't know for sure with SQLite. I would bet if you search around, you can probably find some answers to that. The big thing is that like SQLite is not meant to be a replacement for MySQL. It's not made to have a lot of concurrent connections hitting it. Like imagine, a web server where it's got a separate thread for each request. It might be getting thousands of requests a second. If each of those are trying to hit a single SQLite database, it's going to be annoying. There are going to be some bottlenecks there. Like SQLite is not optimized for that case. Versus MySQL, it's built to handle higher load like that. So yeah, I don't know exact numbers, but if you're starting to ask yourself like, okay, how do I support hundreds of requests a second? Probably not using SQLite is the answer. You probably want to look at a real database engine in that case. And I guess I shouldn't even really say real database engine because SQLite is a real database engine. It is a very nice database engine, but you probably want one that's optimized more for high load concurrent scenarios, which means you're going to want to look at like PostgreSQL or MySQL, things that are like built to keep things in memory and do caching and, be very smart about how they optimize things. You're going to want something like that. So let's see. Someone was wondering what type of Raspberry Pi. This is the Raspberry Pi 3, but the Pi type doesn't matter at all for this this set of videos. It's it's you could use the 0, you could use anything for this. Yeah, it was a DHT 11 or 22 sensor actually that I'm using. And go back to the first video, and I think I have some more links and mention of the sensor and stuff here. Let's see, other questions. Can this be accessed remotely or just from the machine running on the database? Good question. So it's a file on the Raspberry Pi, that dht.db. Anything on the Pi can open that and read it, and like even other programming languages, as long as they have a SQLite kind of interaction layer, they can do it. Things outside of the Pi can talk to it too. Like right now I have this tool called Mac Fusion that mounts my Raspberry Pi as an SSH file system, and then it's that SQLite Studio that I was using, it was connecting to my Pi through that SSH file system and accessing that dht.db file, and that works. That's okay. I wouldn't recommend it again because my SQLite is not meant to have like multiple things talking to it, especially multiple things like writing to it at the same time and stuff like that. So, it's not meant to do it, but it can do it. Like, I think for a while they kind of said that it didn't support it, and nowadays they kind of dialed that back. So I think maybe it would work, but again, it's just something to be careful about. That SQLite is good for like, your program and maybe a few other programs using it on the same machine. When you start thinking about like other machines talking to it, then you really probably want to look at a separate database engine. And I don't know, maybe in a future video, I should look at that might be a good one for like, I only thought this would be like a 2 or 3 part video, but maybe we'll do a 4-part one because I'm kind of thinking maybe the next part, let's look at building like a neat little web interface that uses our database. And then maybe a 4th video, let's look at like going from SQLite to MySQL. Let's use a real database engine and see how that works for this. So cool. And I think that's it. So I think that was all the questions. So thanks a lot for watching. Tune in to twitch.tv/Adafruit, youtube.com/Adafruit. You can watch me stream this stuff live and do all kinds of fun projects. I like to stream on Mondays. I'll do like a quick look at a Raspberry Pi thing. And then Fridays I do more in-depth stream like this. So programming note, Monday I'll have a stream. I'm going to do another quick look on some Raspberry Pi stuff. And then Friday next week, I probably won't have a stream. So I'm going to be out at Tour Camp, Toor Camp. Really cool little hacker camp. It's every 2 years. It's up here in Washington State. I went the last time in 2014, and it was an awesome experience. Really, really neat thing. It's in the style of, if you've ever heard of like Chaos Communication Club or the Chaos Computer Camp or whatever. In Europe, they have a lot of these hacker camps where it really is camping. You're out at a kind of in the woods. Although this one, they're in a really nice little resort, kind of the San Juan Islands. But that'll be fun. It was cool. It's a lot of fun of the like hardware hackers, makers, all kinds of people there. Some neat stuff going on. So I'll be gone Friday next week, so we won't see anything. I might be able to stream some stuff from there, perhaps do a Periscope. We'll see how things go. I think I read that there was a Wi-Fi network. I don't know. We'll see how things go with that. But anyways, so yeah, tune in. I do lots of live streams, and you can see all that kind of fun stuff. And also all kinds of other live streams. So Lady Ada has Desk of Lady Ada. Noah and Pedro have Layer by Layer with 3D printing. All kinds of cool stuff going on with Adafruit. So, like, comment, subscribe. Let us know that you like this stuff and that you get good value from it, and we'll keep doing it. So this is Tony from Adafruit, and that was part 2 of the SQLite sensor storage. Thanks a lot for watching.